got a great presentation for you from Biosynthetic Technologies. They're going to be talking to us about high-performance sustainable base oils. We've got two speakers, and I will be introducing them shortly, but first I have a few administrative things to go over. So that'll only take a few moments. This webinar is being recorded, so if you had a colleague who wanted to join but maybe had a meeting or something of that nature, it is being recorded. The recording will be sent out to everyone tomorrow, so look for that tomorrow. All right, so if you have any sort of audio issues throughout the presentation, you can't get it figured out, you can always give us a call. The number on the screen right there is a direct line to me. I'm the education manager here at STLE. My name is Stefan, and I'll be happy to help you out as best I can. You could also send me a question in the chat as well, and I will try to help you out through there as well. And speaking of the chat, in case you haven't noticed yet, all the attendees, you are in listen-only mode. So you won't be able to use your microphone, but we still do encourage Q&A, and we will actually have a time for Q&A at the end of the presentation. But we want you guys to participate, obviously. So if you locate on the right-hand side of your Cisco WebEx window there, you should see a Q&A section. And it might be collapsed, so you want to hit the little arrow, and that'll open it up, and you'll see a place where you can type a question. Anytime throughout the presentation, if you have a question, please put it in that little chat box there, and I will be keeping track of them. And at the end, we'll go through all the questions with our two speakers. So again, if you have audio issues, give us a call at the number on the screen, and I'll help you out as best I can. And if you have questions throughout, please use the Q&A window, and we will have a time for the Q&A at the end. So one of our speakers today is Matt Kriech. I hope I'm saying his last name right. He has a PhD, and along with being the COO of Biosynthetic Technologies, he supports the Heritage Research Group and the Heritage Group in evaluation of potential new projects and investments. So prior to this role, he led the transition team for the THG and worked for Asphalt Materials, Inc. in developing predictive economic models. He's also served as general manager of the Piezo and supply chain manager, tolling manager, and business excellence leader for Monument Chemical. And Matt received his BA from Wabash College in 2000 and his PhD from the University of Utah. So Matt's got a lot of knowledge to share with us. From what I understand, he's going to be doing a lot of the presentations today, so that's great. And we also have our other speaker today is Mark Miller. And Mark Miller is a entrepreneur and a special emphasis on sustainable technologies. Prior to Biosynthetic Technologies, he co-founded and was CEO of TerraSolve Technologies Limited, an environmentally safe chemical products company. He has engineered, sold, and marketed environmentally acceptable lubricants and base oils for over 30 years. And he has a BS in chemical engineering from Tufts University and an MBA from Manhattan College. So between Mark and Matt, we've got a lot of knowledge and a lot of experience, and we're excited to see what they have to share with us. So I'm going to turn things over to Matt. Stop sharing screen here. All right.
Awesome.
Matt, I'm passing.
I think I have it now. Yeah.
All right.
Excellent. So, yeah, thank you for that introduction, Spawn, and thank everyone out there for taking the time this afternoon to learn a little bit more about Biosynthetic Technologies. So he already did a great introduction of myself and Mark here, so I'll skip that. Just want to highlight real quickly is this is our second FDLE webinar. Mark gave a fantastic high-level overview of kind of biosynthetic technologies, the environmental landscape, and why we got into doing what we're doing, and then some high-level data about materials we're manufacturing and some of the products they'd be suitable for. Today, I'm going to kind of expand on that initial presentation, less high overview, a little bit more into the detail of some of the things that we're doing, especially around our sustainability and life cycle assessment claims, and then items a little more dive into the performance characteristics of finished formulations that we've developed to highlight the technology that we're producing here at Biosynthetic Technologies. So just a real quick overcap of who we are. Our company is really focused on sustainability and performance. So really, our goal is to deliver innovative solutions for a sustainable future. And I love it because all the employees here at BT really believe that, and I think we're making a great impact and hope to prove that to you today, really around sustainability and performance, both environmental performance, technical performance, and performance of your lubricants and how they operate. So real quickly, building off once again Mark's presentation, is the key technology that we're driving here is called an estolide. Estolide came out of research and development from the U.S. Department of Agriculture a little over a decade ago. And what they do is they allow you to take a free fatty acid from any type of oleic-based oil. So it could be, oleic from soybeans, high oleic soybean oil. It could be ricinoleic acid coming out of castor. It could be, even oleic from, like, say, tallow sources or palm. We just need some type of free fatty acid that has a functionality, and then we can cross-link those fatty acids to make longer and longer chains that are suitable for many types of applications. So what's nice about that is we have a lot of control over this technology. We can choose the fatty acid type. We can choose how many chains we put together. This allows us to customize the viscosity of these products from very low viscosities all the way up to very, very high viscosities. So ISO 22 all the way up to ISO 680s and greater. What's also nice is this technology solves some of the problems you see with traditional bio-based products that are used as base oils, mainly around ester technology. The estolide bond is a subclass of an ester bond, but it's a secondary ester. That means it's sterically hindered. That steric hindrance dramatically changes how the molecule hydrolytically degrades. It's one of the biggest mechanisms of failure in esters. And it doesn't make it go away completely, but it dramatically changes the game on how hydrolytically stable they are. And we have some data kind of in the presentation, hopefully to prove that to you. What's also nice is we can customize kind of what's on the end caps of these molecules. So we have kind of usually two groups to further customize our alpha and beta. And so if, some type of surface chemistry is important, maybe it's sulfur, maybe it's phosphorus, we can do that. We can take alcohols that are also very hydrolytically stable in our beta group. We can leave free OHs if high polarity or surface contact is important. It allows a lot of tailorability of the molecule. And this is the technology that really drives everything you're going to see here today in our presentation. What I will say is for round one of our products that we'll highlight here quickly is we really focused on oxidative stability, hydrolytic stability, good emulsibility, and okay to good cold temperature properties. We can further enhance those, but once again, really oxidative and hydrolytic stability have been our big focus to make sure these things perform well from an overall environmental and performance impact. So one thing we do want to think, though, is I know we're talking a lot today about lubricants, but we really view this estolide technology as a platform. We've actually developed products using our BT base oils in a number of applications, carriers and adjuvants in agriculture. Our low viscosity products we're working in for making as a plasticizer in plastics. Obviously, we'll talk a lot today about lubricants and the lubricant industry. We've used the BT estolide technology to replace process oils and tires and saw very good kind of cold weather and winter type property in those tires. We have HX1 certification for non-food contact. We've also researched around being able to use them as emulsifiers in food. And we have a personal care division that's exploring use in cosmetics, skin creams, hand creams, lotions, due to its good emolliency. And so what's nice about this is it's a platform that can leverage the technology across a wide array of industries. The other thing we like to talk about is we have a great IP portfolio, which with the focus of really protecting our customers. We want to make sure our customers are free to use our technology without a concern of being blocked by some type of other patent or technology. So we have patented kind of all the way from the original raw material sources all the way down to in-product application. So you know, the raw materials you're using it, the technology, the proprietary catalysts, the processing of that, and then the end formulations. We've got about 71 patents that have been issued so that you can really operate with freedom for any of the work you're doing with our Estolide technology. So today we're talking about kind of the base oil components for Estolides. We have three current key product offerings. We call them BT4, BT22, and BT75. This is essentially their viscosity, so from a thin material to a thick material. All have very good bio-based content. Our lowest is 68% with the BT4, all the way up to 94% with the BT75. The reason for the change in the bio content is we're capping right now with a alcohol that's non-bio-based to improve hydrolytic stability overall. So then the bigger the molecule gets, the more bio-based content, which is why the 75, which is roughly 12 to 15 chains of our fatty acid glued together, has kind of the best bio-based content. Here's the general physical properties of our base oils. So you can see it's roughly an ISO 22 for the lowest viscosity up to about an ISO 680 for the 75. These materials are fully blendable with each other. They're a very solvent molecule, which we'll show kind of down further in the presentation. What that means is you can easily blend the BT4 and the BT20 for ISO grades, so like a 46 for a hydraulic fluid, or if you need an ISO 220 gear oil, the BT22 and the BT75 would be a perfect blend. So really you can blend to any needed viscosity from that ISO 22 up to ISO 680. Very good viscosity index for these products, almost 200 for the BT75. Our pour points for this version is usually in the minus 21 to minus 24 region. Very high flash points, very stable molecules under temperature, 240 minimum up to 270. We're usually seeing from batch to batch variability. We start with very low acid numbers, once again with a focus on hydrolytic stability. You have good colors, usually 1 or less for D1500 on the 4 and the 22, and usually 2 or less, and we've even had close to 1 on the BT75 as well. One other thing maybe to point out is that the BT4, which is a very thin material, has a very good NOAC. It's not very volatile, so if volatility is an issue in your application, the BT4 is a good NOAC. So John, I saw your comment there on the thing is we have worked with 4-point depressants with this technology. I'll show you some of the data in our finished formulations. In general, we see okay response, maybe 3, 4, 5 degrees, but we don't see the type of response you might see with, say, group 1, 2, or 3 technology at this point. From an environmental performance standpoint, we've measured the biodegradability of the molecules as well as the toxicity. And so the BT4 product is a readily biodegradable product. That means it's greater than 60% in a 30-day window. And once primary biodegradation is started, that actually finishes within a 10-day window at 60%. And the BT22 and the BT75 are both ultimately biodegradable. You know, the real goal here is to get to ultimately biodegradable for things like VGP and eco-label applications. You got to be greater than 60%. And once again, usually longer chain, higher molecular weight species like the 22 and 75 can struggle with biodegradability. As you can see, we get very good numbers for our products with the high bio content. We've also tested all the toxicity requirements, once again, to meet Lustless approval for eco-label and VGP type applications. We actually tested at 10 times the required limits, and so instead of 100 ppm, we've done it 1,000 ppm or milligrams per liter. And once again, we essentially have no toxicity across all the species that are required for testing. So it's a very safe molecule if it gets in the environment, and then even if it gets in the environment, it doesn't stay around very long because it's very biodegradable. So very good environmental performance for our molecules. We have a number of certifications and approvals, so you can use these with ease. We are TSCA approved here in the U.S. and Canada. We have REACH compliance in Europe for all the products. We're eco-label and lust listed. We meet bio-preferred content for a number of applications. We have food content, HX1 certification, both from INS and NSF, although those companies have merged now, so it's really an NSF certification. So we're eco-label approved. If you need it, we have kosher, halal, non-GMO, and vegetarian certifications. So if there's something you're looking for your product, there's a very good chance that we can deliver it due to how we produce these materials. If also there's some other regulatory requirement that's needed and some other reason you don't see listed, there's a good chance we've either have it, have started it, or we can work with you to acquire that. So before I have two performance data, wanted to share some of the work we've done around ensuring our products are ultimately sustainable. And so what we've done at BT is our goal is to provide a high-level life cycle assessment to our customers for all the combinations of feedstocks and manufacturing configurations that we use to produce our products. Just out of transparency, is we are an asset-light company. We mainly partner with tollers to produce our products throughout the world. We have tolling contracts on multiple continents to do that. And what we're trying to do is then create life cycle assessments with our partners all the way from kind of the start of the growing of the oleic derived or the oleo-derived chemistry we're using to the final product getting ready to leave the gate of our manufacturing facilities. You know, a good example of this is if we would do a study on, say, high oleic soy oil derived fatty acids that are used in production of BT4 that might be produced in a plant here in the United States that's ultimately used for our passenger car motor oil products. Or in another cases, we have Castor Derived fatty acids they use in making the BT22 and 75. Those are produced in India, and we might be using them for hydraulic fluids. So that's the idea that we try to provide to our customers. In general, we want to use the ISO 14040 methodology, but we probably keep it a little higher level than it's called for in that ISO. And in general, we're thinking kind of 10 key areas when we do our life cycle assessment. Things around like global warming potential, how much CO2 is emitted, methane, et cetera. Acidification potential, really around SOx and NOx emissions. The types of fuels being used to actually produce the materials. Now, this will impact, obviously, the CO2. There's other impacts as well. So we're looking at fossil fuel depletion. Habitat alteration. I think this is a very important issue, especially when you're dealing with oleochemistry. Are you competing with things that, like, say, land that's being used for other purposes? Are you deforesting? What's the impact as you grow? Air pollutants, especially particulate emission when you're working. Human health, we look a lot around the socioeconomic impact of our product and how it's manufactured. Are there GMO implications? Smog, ecological toxicity, so aquatic and soil toxicity, heavy metal contamination, water utilization in growing these crops, and the overall kind of air quality, especially around agricultural impact and production processes. And so we've done that, and the one I want to share today quickly is the Castor Derivative LCAs. So we partnered with Gujarat Agriculture University to look at all the way from the start of the seed planting for Castor products through the collection of those materials, delivery to the processing facilities, and eventually turning that into an intermediate and a final product for BT. And so we partnered with, let's say, the Agriculture University, our Indian toller manufacturer and their research and development department, and then our team here to kind of map that out. We drew out essentially all the high-level inputs and outputs for these systems, and I won't go this into detail, but it looks at things like how much seed you use per acre, how much nitrogen, phosphorus, sulfur is required, are you using insecticides, herbicides, what's the general yield of the castor plot, how close are they planted together, how much water is needed from irrigation, how are they harvested, how are they transported, and we went through that in this study. And what we found is from a number standpoint, when you put all that together and you look at every step of this process, the seed farming all the way to the final product, is the big impact is the land that you're using to grow to castor is essentially dedicated to castor. And it's not like we're clearing a rainforest or other trees, and it's really kind of, semi-arid region that's kind of scrubland that's being turned into agricultural. So in a lot of ways, it's a big carbon sink for CO2. So in that impact, there's a really large negative carbon uptake from that product. And then the biggest component of that carbon is that they take the waste of the seed crushing process, so the spent mill from that castor, and it's actually what's used to drive the boilers that produce the steam for the oil refining, for the initial, ricinoleic or the fat splitting, and then the ricinoleic production, and the 12-hydroxysteric, and finally our process. And so most of the carbon offset is coming from burning that CO2 that was captured and then offsetting that from the steam produced. Now, what's nice about that, though, is we're not using any natural gas or coal or fuel oil to drive those boilers. It's just that castor mill, and so the carbon offset is minimized greatly. So from a high-level standpoint, what that really means is our product leaves our customer's facility with a net negative 9-ton carbon CO2 balance. And that allows us to actually transport our materials across oceans and still arrive in a negative carbon footprint when it arrives to our customers. Now, the end use of the product will ultimately dictate the full life cycle assessment. Since we don't know that for all of our customers, we can't quite calculate that. But what we do to our customers is we give them the state from all the components you see as it's at our gate, ready to be delivered to them. And then if there's a desire to move the life cycle assessment further, we can do that. So if you summarize all that up, though, of like all that impact we talked about, this is kind of what our LCA from a high level looks like. Is we actually went, we visited the fields, we visited with the Castor Consortium in India, we visited the plants, we did the audit, and we really do like the overall sustainability story with castor. One is castor doesn't compete with food crops. It's really land that's not being used for anything else, and allows some of the poorest farmers to come out of poverty. Crops can be harvested multiple times. It's done by humans, so there's low CO2 balance. There's no GMO implications. It's all naturally derived castor. You're not competing with food. And then the way it's manufacturing at our manufacturing facility by using wind turbines, boilers that use castor spent cake, and the high level of integration in that province region of India allows us to be a very sustainable and carbon negative manufactured product. So, so moving on, I did, by the way, see a few questions. I will get to those down the road here, since we're kind of moving out of that subject. But start talking now a little bit about the actual base oils of our products, the properties of the base oils. Real quickly, one, to highlight the solvency capability of the BT base oils. This is aniline point, the ASTM G611 test. This is measured as a base oil, so it's 100% of the component. And what you see is the BT75, the BT4, and the BT22 have some of the lowest aniline points measured. What that relates to is these are very solvent molecules. It means they blend well with everything. We've experimented in blending with PAGs, PAOs, other esters, group 1, 2s, and 3s. And we see very, very good solvency, even with kind of all the additive technologies. So it's solvency is something that's important to you. It's something you need. Even small street rates of our products can help you. The other we talked about as a key component was hydrolytic. We've run the Estolide on both the standard kind of ASTM D2619 test. We did modify that. It's usually a 48-hour test. We modified it out to 144 hours just so that we could show how hydrolytically stable these materials are. Normally, an ester would start to have problems at 48 hours, but we don't really see much change at 48 hours, which is why we modify it out to 144. We compared, for example, this is our ISO 680, which has if you think about it, those are 12 to 15 chains that are glued together. So there's lots of those secondary ester bonds to attack. But even at 144 hours, we see very little change in the acidity of the water layer, 0.17. And we compared that what we see to things like in PAO and bright stocks that are traditionally very stable hydrolytically. The Estolide favors very well. But this kind of wasn't good enough for us. We really wanted to highlight really how well that estolide bond affects the hydrolytic stability. So we created what we call the hydrolytic stability torture test. Here we'll take a product, we mix it with 1% water, we heat it up to 180 degrees Fahrenheit, and we stir at 500 RPM nonstop. We ran an 8-week study, and so you can kind of see what the test apparatus looks like in the picture below. But each one of those vials is basically a test. Each week we pull. And then we looked at a number of things. We looked at our BT products. We looked at low-vis and high-vis PAGs. We looked at group 3s. We looked at low-vis and high-vis PAO. And then we looked at a whole range of esters, so complex esters, C8 polyol ester, a diester, a C18 polyol ester, and then compared the results. As expected, the low-vis, high-vis PAGs, the group 3s, low-vis and high-vis PAO, they're essentially a flat line. There's almost no change in tan with time, and they really never come off the ground. Whereas the esters, you can see here, I have pointed out as traditional esters, they rise very rapidly in these types of conditions. You're getting the hydrolytic cleavage of that primary ester bond. You see a really rapid increase in the tan. The BT products, the 4, 22, and 75, they essentially stay flat all the way out to week 4, and then finally at week 8, we saw kind of the first rise in tan up to about a 0.7 to 1, which is still a relatively good number for tan. And so it just kind of shows from an order of magnitude how much better those secondary esters are from a hydrolytic stability. Did a similar test. We used the RDPOT test methodology here, the ASTM D2072, to look at oxidative stability of the products against the same class of molecules. And once again, what you see is our products, when you mix it with a 0.5% phenolic, 0.5% anemic treat rate antioxidant, performs similar to what you get from like a group 3 or a low-vis PAO, and dramatically better than what you get from kind of low-vis, high-vis PAGs, high-vis PAOs, and most of the ester classes. So once again, really kind of best-in-class oxidative stability. And this is achieved through us using fully saturated materials. There are no double bonds that would impact the capability of that oxidative stability. So next, I want to talk a little bit about some of our prototype formulations. And what we're doing here at BT is just want to remind everybody is our goal is to be a supplier of base oils and additives out to the lubricant industry. The only reason we're really making finished formulations here is just to highlight how well our technology works. So, and we want to do this in a range of applications from gear oils, hydraulic fluids, PCMO, grease, and metalworking fluid data, which we'll talk about. But once again, and as a small caveat to that, we are currently selling GF5 certified PCMO that was made using our Estolide technology with high oleic soy oil that is available for sale. But once again, our end goal there is really to partner or license that technology with a finished fluid formulator, not to be in a business selling motor oil ourselves. And so hopefully, what we're trying to do here is prove to you the technology works in final formulations and maybe help speed you to a use of the technology down the road. So first up is gear oils. The first is a ISO 220 gear oil we made, eco-label compliant. This used so essentially 100% of the Estolide technology, so it was a blend of our BT75 and the BT22, so about 67% and 30%. 4 point, as expected, was around that -20, -21 that we normally see. We got a very good VI on the product. Once again, like to point out, even with the ad pack, a very high flash point for this type of oil, so very low volatility. We see this in the BT products. They tend to impart very good wear, so a very low 4-ball wear scar with only 0.32. Was also having a relatively good weld load. So the last weld point was 315 kilograms. We did rust testing, which is sometimes an issue with these components, and saw really good results. You kind of see what the gear oil too looks here. The color is actually pretty good for gear oil. We then, once we felt like we had a relatively good gear oil to simulate, we took it out and we did it and compared it to kind of some of the DIN and China GB specs, as well as some commercial gear oil products of the same ISO grade, the ISO 220 grade, out on the market, and kind of ran it through the test points. And so what you can see is some key points to highlight is, once again, you see the low tan of our product starting, which is always good. We had similar flash points. Our pour points were a little bit higher in the -20s versus kind of the -30s you see. But this is where we do see some of the problems that we talk about here. Is if you look at the rust performance, one of the commercial products, it did not pass when we ran it multiple times, whereas we got a good pass on the rust. Demulsibility, remember, this is one area we focused on heavily with our products, and so we really got the best demulsibility compared to the commercial products. You see we had the zero kind of rag layer. It's some in the commercial A product, and the commercial B product actually did not pass demulsibility. Sometimes you see this with bio-based products as well. It's foam, and here we ran the Flender foam test. We were able to pass. Commercial B passed quite well. So you can see the commercial A had some product as well. So really, of all this kind of test suite, and once again, oxidative stability, we kind of the lowest measured value here, which we expect as well. So very good oxidative stability result for this material. So what you can see is the things that we were really focusing on, hydrolytic stability, oxidative stability, demulsibility, seem to pan out, especially compared to the commercial products on the market. So we're really happy with the performance we're seeing from these gear oils. And it's a fully eco-label compliant. All the components are less listed components. And so you could use this for a number of good applications. So now moving on from gear oil is we did make a prototype grease formulation with our BT22 product. Here the goal was to make a lithium grease. So it was about 85% of our BT22. We focused on using a pre-blended lithium 12-hydroxystearate component. You can see the rest of kind of the additive package that was used to make the grease. Cooked at 220 degrees Celsius and homogenized at 6,000 psi, and it made actually a really nice looking grease. We then once again put it through some initial testing and compared it with some of the GCLB specifications out there. So color was kind of a light tan color, a good 4-ball wear, a very good coefficient of friction, very good work penetration of 276. We were targeting an LGI grade 2 grease, which we did produce. Good dropping points from material. You see the 4-ball wear 0.42. Once again, that's kind of similar to what we see with most of our products, because the Estolide, we believe, seems to have a ability and impart good wear protection and load carrying capability onto the fluids it's used in. Low temperature viscosity came in where we would expect. Usually, once again, kind of these -21 to -25. We got a -23. Oxidation time to exotherm, this would be expected. These are very oxidatively stable. And the weld pressure load topped out around 315, which once again we saw with some similar data for our gear oil. So overall, which sometimes bio-based stocks and esters can have an issue in actually making greases. Once again, it's really derived around hydrolytic stability in the cooking process. We're doing more work to kind of prove that out, but we think one of the great advantages of Estolides is you can actually use them as a suitable base oil and greases because of this improved hydrolytic stability. So it opens up more possibilities in the grease world compared to prior bio-based base fluids. All right, next, moving on to hydraulic fluids with the BT products. And the focus of our hydraulic platform was really to understand and to prove that we play well with other base fluid technologies. Earlier in the presentation, I talked a lot about the solvency of the Estolide product, so very low aniline points, which means it blends well. We just wanted to highlight that we do blend well with other components, and that we can actually take on some of the properties of those component blends when we do it. So our first hydrolytic formulation was an ISO 46 that was done with a PAO blend. Here we used the BT22 product at about 68% and then a PAO2 Centistoke. The reason we chose PAO2 was, once again, to show the blending capability, but also to keep the biodegradability of the overall end product. And as you see, because of the good pour point on the PaO2, it did improve the overall pour point, even though we're using a high relative amount of that BT22 product at almost 60, 68, 69%. So we got a minus 32. Very good VI, which we normally see. Flash point here, you saw a dramatic reduction in the flash point because of that high volatility of that PaO2 compound. But it actually brought the volatility up quite a bit from what you see with just, say, like a PaO2 product. As expected, a very good oxidative stability of about 823 minutes for end or hard break. We did run hydrolytic stability testing on these products, and essentially, the total change in water layer was really 0.01, so very hydrolytically stable. That makes sense, especially when you're blending it with PAO. So I think a quality product produced here. It shows we work really well with PAO technology to kind of take on some of the properties of that PAO when it's used in the formulation. So if you have PAO formulations, we also actually improved the solubility and solvency as well. We saw it made mixing in the additives very easy because of the solvency nature of that BT22 product. Now, kind of complementing that is we also made a BGB compliant hydraulic formulation. And so the way we did this is we actually used our BT22 product with a 4 centistoke group 3 product. And this, because it was 4 centistoke, we actually used more than we did, say, of the PAO. It's 59%. We were about 40% of the overall formulation. Now, you think that might have some issues around maybe toxicity or biodegradability, but what we found here is that our estolides imparted really still very good biodegradation ecotoxicity performance. So we reran the OCD 301B and got 75% for the overall biodegradability, which we thought was excellent. Once again, to be BGP compliant, you need to be above 60%. And then we ran the OECD 201, 202, 203 tests, 100 ppm as required by VGP and Ecolabel. They were all found to be not acutely toxic, which once again, a great result. So really good environmental performance with this formulation. We also ran kind of the standard performance data that you would expect, like we were showing in previous data. Pour point of minus 26, so kind of what you normally see with, say, a group 3, and once again, our component, not unexpected. Good flash point, really good color, once again, less than 1. We ran, obviously, corrosion testing, passed no problem there. Rust testing, no issues. We ran hydrolytic stability, very good numbers. Demulsibility, once again, 40-40, no rag layer, passed in 15 minutes. 0 foam issues. 4-ball wear of about 0.41, a little bit higher. Once again, we're not using as much BT22 and normal load. And the weld load was a little bit lower at 160. This is not surprising, it being a thinner material, but once again, lower volume of the BT22 product. And you can see the hydrolytic stability around 0.24, so a good number, and oxidative stability of about 600 minutes. So still very oxidatively stable being imparted from that BT22 product. So what's nice about this is it's very different than a PAO blend. The cost economics are different, but we can still drive environmental performance. We can still drive a lot of performance with this fluid formulation. So it's a way of thinking about it from 2 classes, and I think shows that we've kind of played real well with both types of technology. So next up is a passenger car motor oil. And we actually have 2 API certified GF5 motor oils. One's a 5W30 product, and a 5W20. These contain roughly 35% of our Estolide technology. In the case of our PCMO, this is a technology built around our high oleic soy oil. So it's high oleic soy oil derived estolides that we use to produce this. And once again, the things that we like about this when working with motor oil is the good VI, and we talked about that solvency, the low aniline point. So it imparts a lot of good natural detergency and solvency to keep the engines clean, and that kind of shows itself well in the data. You can kind of see the results from a field trial we'll talk about below, but it talks about the good cleanliness and solvency that the Estolide imparts from a motor oil perspective. So once again, just wanted to clarify, so we are selling this product as a commercial product, but we're really looking for a partner that would love the license or partner with us to create these finished formulations, especially when it comes to now the GF6 motor oils that are coming online now, which we'll talk about here in a second. So first up, just kind of the general analysis of what we saw with our 5W30 motor oil. You can see the KV 140. It was designed to say to be a 5W30. Past CCS and MRV with really no problem at all. With the pour point, being the minus 23 or so, sometimes there's concern, but once again, we saw no issue with our products with the full temperature properties. And that 8% NOAC, that's once again being driven high by that low volatility that we see with that Estolide technology. We did do the full sequence testing required to get the API certification. The sequence 3G here, once again, you see that weighted piston deposit, which kind of shows, once again, that good cleanliness capability, good solvency capability of that Estolide, imparting that there in the formulation. The bio content comes in around 29%, which allows us to meet the USDA bio-preferred metric, that's 25% requirement in motor oil. So this is a USDA bio-preferred certified engine oil. And then, I said we have the rest of the 4A, and the other sequence tests, and we're happy to share this afterwards if you have interest. What was nice is we actually passed this, all of the sequence testing first time through with our Estolide formulation, which once again, highlights, I think, how well the Estolide technology can perform, even in a demanding application like passenger car motor oil. To also demonstrate the capability, we ran a field trial with our PCMO out in the Las Vegas, Nevada desert. We used a taxi cab fleet out there, so stop and go in desert conditions was about as bad as we could think, and that's what we wanted to put it through. We ran the test for about 150,000 miles. We ran one engine, one taxi cab on a conventional motor oil, and the other on our 5W20 certified Estolide motor oil. And then we took those engines and actually had them cut up. And the demonstration we actually usually have an exhibit when we're at FTLE. So next time we're able to get together in person, please stop by our booth and I'll show you that engine in person. I would love nothing more to be able to do that instead of virtually, but the pictures will have to suffice today. You can clearly see the difference. Here's the conventional motor oil, the varnish that deposits a little over time. Once again, that good solvency from the Estolide really keeps that engine nice and clean looking, which I think highlights the technology well. We are working on a GF6 motor oil as we speak. We're trying to find a partner to do this with us. Once again, I said we don't want to be a finished formulator for these products. We have blended up using our new BT4 technology down to 0W20. We have a 0W20 and a 5W30 blend for GF6. We've done some of the initial bench testing, are getting ready to start doing some engine testing, and eventually get that for our GF6 certification for our motor oil. We have some initial results around, obviously, viscosity and CCS. Everything's looking very good for us to be able to meet the 0W20 technology. And that's really being driven by the new BT4 technology. The original technology to get the 5W20 and 5W30 was actually a 6 ANSO product. Our research with this new BT4 product allowed us to go lower in the 0W20, and I think that's really exciting. So next up, I'll talk a little bit about metalworking. But before I get too far into metalworking, is one thing that we realize is sometimes metalworking has different requirements than some of the traditional base fluids you have in other industrial applications like gear oils, greases, hydraulic fluids, like we talked about. So what we've done is we've kind of retailored our Estolide technology basically make effective additives for the metalworking fluid. We call this the BioSeal line. It's derived from Castor type materials, which is where the name is derived from. And each one of these additives is really designed to kind of tackle different areas in the metalworking application. So our BioSeal 1 really is a focus around cutting and grinding applications. Our BioSeal 2 is more around general machining, whereas our BioSeal 3 is really around forming type applications. We started to do some early benchmarking against what I would call traditional competitors in this space, like pentaerythritol esters, synthetic esters, TMPTO, and some of the other, maybe even Castor derivatives. And you can see the kind of the rough molecular weight for these molecules. We've just recently developed these additive technologies. We've done a little bit of testing, and this is kind of the first data that we get to share. The big one here is we get a twist compression test. And what you kind of see compared to the traditional bio-based stocks that are used in metalworking, especially the BioSia 3, designed for kind of a higher polarity type environment, just did phenomenal. It's one of the best tests they've seen from a twist compression standpoint. Kind of essentially world-class performance of that Estolide technology that we've developed. We're going to continue to develop more in the metalworking space. We've recently brought on a new formulator and researcher and commercial guy in the metal space, and Jeff Mackey. We're excited to have him on board and he can develop this space for us to look for more exciting things to come in the metalworking application space. One last thing I'd love to highlight is that we are starting to branch out into a larger portfolio of products that we can offer our customers. Okay, we have the Estolide base oil technology, we have the Biosia additive technology line. We're now working with our Indian partners to be able to offer more specialty Castor derivatives in the marketplace. And so we now have an additional, I think, 7 products that we're bringing online. These are polyracilonic acids, acid values from 30 all the way out to 100. We have a diethylhexyl sebacate molecule, which is a very low pore diester. So it's got a minus 70 pore point. And so if you need applications where pore point is really good and still have the bio content, this is a molecule that we can deliver to you. Bis hydroxyl and disodium sebacate, other additives used in the metalworking space. I did see a question just pop up. Sorry that someone asked about, are these group 5 base oils? We are working actually, traditionally you would think of esters in a group 5 space, but because of some of the technology we're employing, we're actually working with API right now we meet the qualifications of a group 3 as well. So around sulfur content, around overall saturate level, around VI limits. And so they meet all the requirements of a group 3 so that we might be able to get a good read across from our GF5 to our GF6 for those base oil components. Just answering your question that popped up. I'd be happy to talk more about that. Also on the specialty Castor derivatives, I just want to show a little bit of data on our poly-RA50. We ran twist compression and 4-ball wear, and we've compared it to some of the other products you'd use in the metalworking space. Would be chlorinated paraffins, polymeric esters, and sulfurized esters. And once again, you see the poly-RA product that we're manufacturing has really good kind of best-in-class twist compression compared to the other products. And the 4-ball wear is quite low, very similar to what you'd see with, say, a sulfurized ester of 0.72. You get a around 0.7 with sulfurized ester, so much better than a chlorinated paraffin and the polymeric esters being out there. Once again, these were kind of used at 15% concentration rates from a dilution standpoint. And you'll see more of this to come as we keep on working on our metalworking and additive technology. But once again, just to repeat, is our goal is to supply these materials as additives to the metalworking industry. So the metalworking fluid formulators, we want to partner with them to sell these. We are not entering the metalworking finished lubricant space. We just want to be a supplier and additive manufacturer for these components. All right, so that kind of gets to the end of my overall performance data discussion. And I think I had to leave about 15 minutes for questions, so I think I did okay there. But I would be amiss, and my marketing person would kill me if I didn't point out all of the awesome ways you can follow updates at Biosynthetic Technologies. We keep a very updated profile on LinkedIn, so please like us, follow us there. We're always putting up some exciting picture of new stuff we're working on from a research perspective. Our website has fresh content. You can download all the technical data sheets, any other white papers that we may publish out there on our blog. So, and yes, I did see a question that we will be able to share these slides. We'll be posting the presentation online, but I'm happy to share these slides with you after as well. So, and with that, I'll leave you with, hopefully I've convinced you that we're delivering innovations for a sustainable future, and be happy to answer any questions I missed as they popped up in Q&A and any new questions you might have.
All right, Matt, thanks. We've got a couple questions here.
All right, so I saw that. How about thermal stability? Thermal stability, the BT4, 22, and 75. I don't know if I have any data to share. We've actually looked at it, its capabilities as heat transfer fluids. They tend to be very thermally stable. I couldn't tell you over the entire range that they work. We don't see decomposition at significant high temperatures. Like I say, you start to see low flash at around 270, where some of our volatiles start to drive off. So there was a note around echoing. I apologize. Would you please share the molecular weight information? We can share the molecular weight information. I apologize, I don't have it off the top of my head. Just roughly, a BT75 is roughly 12 to 15 C18 groups spaced together. The BT22 is roughly 5 to 7 of those linked together, and the BT4 is the smallest unit. So, we do actually have products at 4 points lower than -30 that we worked on right now. We have produced early material of the BT4 at 4 points all the way down to -47, but we're still working on how we would commercially produce that material. We have ways of producing the 22 and the 75 at 4 points at -35 to -37. The only thing about that is when we go to those 4 points, we have to employ some double bond technology to get there, and that does affect the oxidative stability. We actually have a white paper on our website, but we can have that sent over to you, that actually explores that product, our low pore products, and how you trade off oxidative stability for pour point with the estolides. And then that is currently out on our website. The BT bio-based content, it goes from 68 to 94%, and we have those in our technical data sheets we can share. I don't have toast times off the top of my head. Once again, I'm happy to share that data with you.
All right. Well, Matt, thank you. If there are any other questions, please, everyone, just put them in the Q&A, and we'll have Matt answer them. We appreciate everyone's time from Biosynthetic Technologies. And so, yeah, if you have questions, please put them in chat. I will be sending out all the contact information for everyone there at Biosynthetic with the recording tomorrow. So if you have questions that come up after that, please shoot them an email.
I did get a few more questions in, I think, my personal chat. So there was a question, is oxidation over time an issue with these bio-based materials? Not that we've seen. I think they tend to behave very similar to other oxidatively stable compounds like PAO. Once again, it's mainly driven by not having a double bond. There's not much to attack. The larger concern over a long time is always hydrolytic stability because of that ester bond. But once again, I think we've proved that secondary works. We have lots of CO compatibility testing. NBR, we've done HNBR, NBR1, FKM. Our products can pass all of those. In general, NBRs and NBR1s, HNBRs and NBR1s and esters sometimes can behave weird. What I'll tell you is our low viscosity product, the BT4, tends to behave like a traditional ester in HNBR and NBR1, and our high viscosity products almost act more like PAO. in NBR and in NBR1. There's kind of a flip on the hardening versus seal swell, and we really think that has to do with the size of the molecule. No other issues in like SKM, acrylics, anything like that. So very good seal compatibility with these materials. Once again, something we can share if you're interested.
All right, great. Well, while we're waiting for more questions, Matt, do you have any kind of closing statements or anything else you would like to say before we wrap things up?
Yeah, sure. Once again, thanks everyone for taking the time. We love talking about Estolides. Feel free to reach out to me. My contact info is on the website and LinkedIn. Happy to answer any of your technical questions or send you any technical data you might have a question about. If there's an application that you might be interested in using, we're happy to partner with you. We've got a great R&D team here at BT with lots of resources, so we can help formulate, help get testing done, and some of the know-how and things we've learned in formulating our own kind of test products here. So happy to partner and work with you. We think it's a great molecule and look forward to working with you.
Great, Matt. Well, thanks, everyone. Thank you for taking time out of your day today. We appreciate it. And Biosynthetic Technologies, everyone over there, thank you as well. And look for the recording tomorrow and more of their contact information that I'll be sending out.